Today, we're going to talk about a powerful reference-based generation model called Bernini. So what can it do? In this example, it replaces the character in the source video with the girl from the reference image. In this one, it adds a relationship into the video where a man and a woman are reading together. In this one, it replaces the background of the source video with a moonlit scene. And in this one, we only provide a single reference image, and the model makes the character move inside a sea of flowers. So the model we're introducing today is not just a simple video generation model. The most interesting thing about Bernini is not that it generates a random video from scratch. It is that it starts making video editing more controllable and more practical. First, let's explain what Bernini actually is. It is an open source video generation and video editing project from ByteDance. Based on WAN 2.2, if you are a ComfyUI user, you can now use the Bernini model provided by Kijai, together with the Bernini nodes open sourced by RunningHub. Don't understand Bernini only as TRV. Its most important task is video editing, or what we can call reference-gen-based generation. For example, there are several types of tasks. The first one is RVIV, more accurately, in our workflow. This means using a source video plus a reference image to edit the video. The second one is RRV, which means reference gen-to-gen video. The third one is I, which you can understand as image editing. Next, let's first make the ComfyUI setup clear. We need several custom nodes. The first is the Bernini node provided by RunningHub. The most important Bernini conditioning node in the workflow comes from this plugin. The second is Kijai's WanVideoWrapper extension. Since this whole model system is based on the WAN 2.2 ecosystem, almost all the nodes are related to this extension. Now let's talk about the models right now. Kijai provides two sets of models. The first is the FP8 version, and the second is the FP16 version. Following our usual habit, I directly use the FP8 version to run the whole workflow inside it. We have a high noise renderer and a low noise renderer below that. There is also a LightX2V acceleration LoRa. In this video, we'll talk about quite a few workflows, around 7 in total. Here I recommend starting with the reference video editing workflow first. It is relatively simpler and it is also more fun. For easier demonstration, I also built the workflow on RunningHub. In the ComfyUI space, RunningHub is a really great online workflow platform because whenever new models or new extensions appear, it usually follows up very quickly. RunningHub also provides an online community platform for ComfyUI creators where you can find a lot of creative inspiration and practical workflows. Now let's take a look at this workflow. As we mentioned earlier, this workflow is RVIV. That means it uses one reference image and one source video to generate another video. You can simply understand it as a video editing workflow. In this workflow, the function I'm showing you is subject replacement. Our source video is an East Asian woman wearing a qipao, while our reference image is a fashionable girl. In the final result, we perform a replacement. You can see that the overall effect is really good. Now let's look at the main chain of the workflow. First, we input the source video, reference image, and prompt. Second, everything enters Bernini conditioning. Third, we sample with the high noise renderer. Fourth, we sample with the low noise renderer. Fifth, we decode with the VAE. Finally, we output the video. The most important node here is actually Bernini conditioning. It comes from RunningHub and it is similar to the other conditioning nodes we've seen in WAN 2.2. It receives the source video, reference image, negative prompt, and VAE, and then outputs the conditioning and latent needed for later sampling. Next, we have two sampling stages, one for the high noise renderer and one for the low noise renderer. In the current workflow, I use a total of 6 steps. The high noise renderer runs from step 0 to step 3, and the low noise renderer runs from step 3 to step 6. For resolution, you can use many different settings. This depends entirely on your GPU power. Here, I use 480 by 832. For frame count, I set it relatively long. At 145 frames, you must make sure the frame count satisfies the rule of being a multiple of 8 plus 1. If you are running this locally, don't make the frame count this long. I think you can try 81 frames or 121 frames instead. For the sampling algorithm, I usually use LCM, and the scheduler is simple. You can see that the final generated result is still very good. There is one thing we have to talk about here, Bernini's prompts. First, You need to understand that Bernini itself is a video editing model. Its prompts do not need to be especially complex. But based on my testing, I recommend writing the prompt in 3 parts. The first part is a fixed task prefix. This prefix changes depending on the task you are doing. Here, we have a document. You can check which task you are doing and how the corresponding prefix should be written. It is listed very clearly. The second part is the editing goal. In other words, what kind of change do you want to make to the video? We usually use some very distinctive words here, such as replace, add, change, and transform. The third part is very important. You must clearly describe what the edited final image should look like. Now, let's look at the tests. Although I call this testing, pay attention that each workflow used here is slightly different. First, let's look at the first group, subject replacement. We already explained this when introducing the workflow. We have a source video and a reference image. The task is simple. Replace the character in the source video with the girl from the reference image. The actual prompt is made of 2 parts. One part tells the model that I want to replace the main character in the image with the girl from the reference image. Then I also write that the woman is dancing, which describes what the final video should look like. Now, look at the result. First, the character has indeed been replaced. Second, the dance motion follows the source video. Third, the face and clothing remain basically stable across these 145 frames. The performance is very good. The second test is still a video editing task, and the overall workflow does not change much. Our source video shows a man sitting on a bench, reading a book. Our reference image is a highly recognizable, beautiful woman wearing special clothing. My prompt here is also very simple. A man and a woman are sitting on a bench reading a book together. This function is not replacement. It is adding a character. And it is not just adding a character stiffly. There needs to be some interaction between them. Now let's look at the generated result. The overall effect is also very good. The man's position basically does not change, and the environment remains the same as the source video. The woman is placed a bit to the right because she is added on top of the source video, but the overall feeling is still fairly natural. The third test is background replacement. This is also a video editing task. Our source video is a beautiful woman dancing on a stage. Our reference image is a moonlit beach with a glass walkway. Now let's look at the final generated video. The prompt we use is still made of 2 parts. First, we tell the model to change the background. Then I describe what the final image should look like. A beautiful woman dancing under the moonlight. When checking this result, we also look at 4 points. First, has the background clearly changed into the moonlit scene from the reference image? Second, has the foreground woman turned into another person? Third, is there any obvious cutout feeling around the edges? Fourth, do the perspective of the background and the position of the character match, and is the overall lighting consistent? Overall, I think this result is also very beautiful. The fourth test is still a video editing function. It mainly performs style transformation. Our source video shows a woman presenting perfume, while our reference image is actually an anime style image. The prompt says to change the style of this video into the style shown in the reference image. Then I add another sentence, an animated woman is presenting her perfume. After testing this in different ways, I think the result is just average. Look at the result I generated. Part of the character turns into an anime style, but the entire background does not change, and the hair does not really change either. So I recommend not using Bernini for style switching tasks like this. Next, let's look at some other tests. These are no longer simple video editing. First, let's look at R2V, which means reference image to video. We provide a reference image and let it generate a video. Let's start with the simplest case. Here, I only provide one reference image. The fixed prompt prefix needs to change because this is no longer video editing. It is reference-based generation. Look at the generated result. It shows a beautiful woman dancing in a sea of flowers. We check 3 things here. First, whether the character identity matches the reference image and whether the overall performance is stable. Second, whether the motion is natural. Third, whether the flower field and the character blend together well. The generation quality here is quite high. The 6th test is still reference-based generation, but this time with multiple reference images. I provide 3 reference images, an image of a witch, an image of a white tiger, and an image of a staff. My prompt is that a beautiful woman is holding a staff, riding a white tiger, and traveling through a forest. Pay attention. This sentence is very short, but the task is very clear. The woman needs to appear, the white tiger needs to appear, and the staff needs to be in her hand. The final image really does show a woman riding a white tiger through a forest. The difficulty of this group is not about making the image extremely beautiful. The real challenge is whether the model can distinguish the woman, the white tiger, and the staff clearly. Of course, for this kind of multi-image reference, you must be careful not to use too many reference images. Once the number of references increases too much, the overall quality will definitely drop. The final test is I, which means image to image. You can simply understand it as image editing. It is actually the same workflow as reference generation. We only need to reduce the frame count from 140 Gen 5 or 80 Gen 1 down to 1. Our reference image is a very beautiful East Asian woman. My task is to add a pair of red sunglasses to her. Pay attention, this is the task prompt. The fixed prefix in front also needs to change accordingly, because now we are doing image editing. Now look at the final generated result. The red sunglasses appear on the woman's face. Her face is not damaged. The background and clothing are also fully preserved, matching the original image. You'll notice that Bernini supports many different tasks, which is why we say it is a very powerful model. Finally, let's summarize what Bernini is suitable for. I think it is suitable for character replacement in source videos, reference image, guided video editing, adding subjects or relationships between objects, background replacement, single reference, image to video, and multi-reference image to video. When using Bernini, you also need to follow the basic rules of video editing. For example, only do one editing task at a time. Some people write multiple editing tasks into one prompt, trying to change this and change that at the same time. In most cases, that will probably fail. Also pay attention to prompt writing. As we summarized earlier, using a 3-part prompt structure is enough. All right, that's all for today. So what are you waiting for? Go try it yourself. Follow me and become someone who truly understands AI.